Okay, welcome to Chapter 13, Exponential and Logarithmic Functions. Now, Section 13.1 is going to start with the exponential functions. What are exponential functions? Well, those are the functions of the form f of x is equal to some a to the x, where f is the function of x, a has to be greater than 0, and then a cannot be equal to 1. Okay, and when we graph exponential functions, calculator is probably the quickest way, but what we want to do is we want to learn how to do it by plotting points. That's the best way to do it, to see what the properties of the function are like. And so one thing to remember is these graphs never cross the x-axis in the general form. Only when we start applying transformations to the general form, then it will cross the x-axis. And so for this class, the general form is kind of the key one, but you're going to run into ones that do cross the x-axis, and so those you automatically know are not in the general form. So what are the properties of exponential functions? Well, the first property is the domain of an exponential function is all real numbers, and so it goes from negative infinity to positive infinity. Property 2, there are no x-intercepts. We have a y-intercept though at 0, 1. And property 3, if a is greater than 1, the function is increasing, but if a is between 0 and 1, it's going to be a decreasing function. So increasing means it's going up, decreasing means it's going down. And you'll see what we're talking about here once we get to actual graphing these. So our first one we're going to look at is graphing f of x is equal to 2 to the x, okay? And so, while I have this, 10 by 10 kind of graph thing here, some of these are going to go well beyond what's on here, and so we won't really get a good view on the limits where maybe it crosses some axis because it's going to go beyond, but it'll give us kind of a general idea in this area here. So what I'm going to do is I'm just going to choose some numbers. X, let's start at 0, just because 0 is kind of right in the center there. So we'll do 0, maybe we'll do 1 and 2, and then we'll also go the other direction. So we'll do some on the right side and some on the left. So maybe we'll do maybe a -1 and a -2. So now what we have to do is we have to plug in those values into this function. And so then f of 0 is going to be 2 to the 0. Well, what is 2 to the 0? That's 1. And so that gives us the point 0, 1. And they said that should be one of the points, and we do see that it is. Now if we plug in 1, 2 to the 1 is just 2, and so we'll have 1 comma 2. Now if we plug in 2, 2 squared is 4, and so that will give us 2 comma 4. Now if we plug in a -1, that's going to make it be 2 to the -1, or 1 over 2 to the first, and so that's going to give us 1/2, and so -1, 1/2 is going to be that one. And if we plug in a -2, that's going to give us 1 over 2 squared, and that's 1 over 4, and so -2, then 1/4. Okay. Now we just have to plot those points. And so 0, 1, so that'll be about right there. Be nice if the graphing works a little bit better. So that's 0, 1. Then we have 1, 2. So we'll go over 1, up 2. And then we have 2, 4. So that's 2. And that's going to be 4. And then we have a -1, which is about here, and then a half, so it's kind of about that area. And -2, 1/4, so that's about half of the half. And so that's about there. And so now what we have is we have some kind of a graph. And again, it's kind of hard to draw these, but what it's going to do, and then it's going to get really, really, really close to that x-axis, but it never crosses. So, the further and further out you get, you're going to get 1 over whatever 2 to, if you go out here to the 10, it's going to be 1 over 2 to the 10. So it's going to be very, very, very small, but it's still positive, still greater than 0. And so that's kind of be what it's going to look like. And so that's the graph of the function f of x equals 2 to the x. What about this one? Kt is equal to -1/2 to the t. Well, I'm just going to choose the same numbers here. It's easy, 0, 1, 2, -1, -2. So if I plug in 0 here, anything to the 0 power is 1. And in this case, what happens is we do the transformation here, and that gives us a -1. So we get 0, -1. Now, if we plug in a 1, that's going to be 1/2 to the 1 is 1/2, but it's going to be a -1/2. And so we get 1, -1/2. Now, if we plug in a 2, that squared is going to give us 1/4, and it's going to be negative, so it's going to give us -1/4. So 2, -1/4. Now, if we plug in a -1 here, so that's going to be a negative, or 1/2 to the -1, so that's going to flip this over and make it a 2, and then that's going to be a negative, so it's going to be a -2. So -1, -2. And if we square this and then take it to the other side, it's going to be 4/1, and then it's going to be negative, so it's going to give us a -4. And so we have -2, -4. Okay, so 0 minus 1. So now we're on the other side of the x-axis. Then we have 1 minus 1/2. And then we have 2 1/4. So it kind of looks like a mirror reflection as far as these parts. You know, it's going half, quarter, but it's going on this side. And then we have a -1, and then it goes to 2. And we have a -2 goes to -4. And so now what we have is we have this graph that's increasing. And again, it's not going to ever touch the x-axis. It's just going to get really close. And so it's going to look something like that. All right. Let's do another one. Here we have 1/4 to the y. So what are we going to do? Well, you know, let's just go ahead and keep doing the same 6 or 5 numbers we've been doing. We've done 0, 1, 2, -1, -2. Okay, and that kind of gets us, you know, in this area, and then we can go up or down, you know, whatever way it takes us. So 1/4 to the 0, that's 1, and so we'll have that standard point 0, 1. Then we have 1, plug that in here. 1/4 to the 1 is still just 1/4, so it's going to be 1/4. Now if we plug in a 2 here, that's going to be 1 squared over 4 squared, so that's going to give us 1/16. So we're even getting smaller values here, the 16. Now if we plug in a -1, well, that's going to change and flip this fraction around, and so that's going to give us a 4. And so that gives us the -1/4. And if we take it to the -2, it flips it over, makes it a 4 to the second, and the 4 to the second gives us a +16. And so we have that. So 0, 1, so that gives us our point here. Then 1, 1/4, so 1 and 1/4 is really small, right, somewhere in this area. And then we have 2 at 1/16, so it's even closer, really, really, really small. Then we have a -1, and then we have a 4. So that's going to be right there. And like I said, some of them are going to be beyond. So the -2 is going to be at 16, which is going to be way up here somewhere. And so what we know is that it's going to come down. Well, let me start that again. It's not very smooth. So let's erase. Let's maybe go backwards. So it's really, 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 really close. And it goes up. And again, it gets really close. And at the 16, it's going to cross. It's going to have one at the -2, 16. And so it's going to get really close to that -2 until it hits that 16. Then it's going to cross over. Okay. So that's how you graph. Again, you could plug it into your calculator after you've done these and see, do I get the same kind of graph looking thing? So let's try that to kind of show you how that works. So let's clear all that. So let's graph something. Let's clear that one. Let's do just this last one. So we had 1 divided by 4 raised to the x. Okay. Now our window, we know x-min, we can go to -10, we can go up to +10, that's fine. What about our y-min? Well, we know our y-min is just going to be 0 because it's never going to get below that. Now let's do our y max, I don't know, let's do 40 or something, because it's going to go up there a ways, and let's go by 5s. So now let's look and see what our graph looks like. And that's what we kind of expected. You know, it's getting really, really close to 0, never gets there. And then here's our 0, 1, and then, you know, it goes up and up and up. So that's going to be what our graph is, you know, quickly done by the calculator, but, you know, we did it by hand, and sometimes it'll ask you for those points by hand. And so you really have to do it by hand. All right. So we can also solve equations. Now, when we solve equations, we have to have a common base. And a common base means that our a value here has to be the same in both sides of the equation. So a to the m, a to the n. A is going to be the common base. And when that happens, we just take the exponents and set them equal, and then solve from there if need be. If not, then maybe m is your, maybe that's an x, maybe that's a 2, so x equals 2, and we have our equation solved. Now, if they're not the same, what we're going to have to do is rewrite the equation by factoring or some other means to get the bases to be the same. And so maybe you have some number, you know, 2 to the 6th, maybe you have that expanded here, and over here you have 2 to the x. And so you have to figure out what, you know, that 2 to the 6th is and break it down and make it 2 to the 6th instead of like 216, and simplify it that way. And then after that, we can go and we can simplify it using our little common base thing and setting the exponents equal. Now, if we don't do that, what we're going to have to do is do logarithmic functions, and that's going to be in the next section. So right now, we are not supposed to be able to know how to do that. So that's why we have to actually get those bases to be the same. So let's look here. So here we see, okay, well, 3 and 3 are the same bases. So what we do is we just set the exponents equal, and we solve for x. So we divide by -2, and so x equals a -3/2. And that's all we have to do, okay? Now you can always check and plug it back into your equation, and if you plug in -3/2 here, it's going to become positive. The 2's cancel and you have 3, and so 3 to the 3 equals 3 to the 3, so that makes sense. Now here's one where we have something that's to the 64 to the b, and here we have 2 to the 5th. Well, 64, if you think about that, that's 2 times 2, that's 4, times 2, that's 8, times 2 is 16, times 2 is 32, times 2 is 64. So we have 1, 2, 3, 4, 5, 6. All right, so 2 to the 6th, and then when you take a power to the something with the power here, it's just going to be multiplied. So it's 2 to the 6b equals 2 to the 5th. Now we have like bases, so we can say 6b equals 5, divide by 6, b equals 5/6, okay? And then that would be our solution. And again, you know, if we plugged it into our calculator, we could see if that was truly the case. Take 64, raise it to the 5/6, and then take 2 to the 5th and see if they're equal. All right, what about this one? Well, we have a 4 here and we have a 1 here. Well, what are we going to do? Well, some of our properties we saw before, you know, if we take something, say x, raise it to the power 0, that's 1. So since we have a base here of 4, let's change this to, now let's keep that as 4 to the 2a, 4 to the 0, because if we replace the x with 4, 4 to the 0 is also 1. And so then we have equal bases, and we set those equal. So 2a equals 0, divide by 2, a is, oops, not equal to a, it's equal to 0, is equal to 0, and that would be our solution. And if we think about it, if we take 2 times 0 is 0, 4 to the 0 is 1, that makes it so it does work. But we had to first get this into the same base, and so we just take whatever the base is here. It could have been 250, and we just say, well, okay, it's 250 to the 0, and then we just set those equal, and then our value is a equals 0 in this case. All right, what about the next one? Well, here we have something base 6. Here we have something 1 over 36. Well, what do we know about 36? Well, that's 6 times 6. And we know that that means that's 6 squared. and it's in the denominator. Well, if we put it in the numerator, then we would have the same base. And so 1 over 6 squared is equal to 6 to the minus 2, because we take it to the top and change the sign, and we get the same base. Then we have the 6, and so we can say 6 to the 2m plus 1 equals 6 to the negative 2. Same bases now, so now we just set those equal. So 2m plus 1 equals negative 2. Subtract 1. 2m equals negative 3, divide by 2, m equals negative 3 halves. And so that would be our solution. So again, this time we had to think about, well, what does this represent? Can we get it to be something with a base of 6? Well, 36 was the 6 times 6, so that's 6 squared. We know if we take it to the numerator, we just change the sign, we get a negative 2, and then we have our like bases. All right, what about the next one? Well, the next one's back to something simple again. We have a base 4, base 4. We can set those equal. So 3a equals 3. Well, divide by 3, and a is equal to 1. So that's another one of those. It's really easy. It's set up nicely. All we do is we take and set those two exponents equal. What about this one? Well, this one, we have a 9 to the 2n plus 3, and we have 243. Well, 9, I know, is 3 squared, and then that's times 2 to the n plus 3, because that raised to that power is going to just be multiplying. Well, can I get 243 in a base of 3? Well, what do we have? Well, 3 times 3 is 9, times 3 is 27, times 3 is going to be 27 times 3. Let's see here. That's going to be, multiply that out. 81 times 3 again is 243. So that's going to be 2 to the 5th. Okay, so, or 3 to the 5th, sorry, because we're using threes. So we have 3 to the 5th. So now we have like bases. Okay, well, this one is 4n plus 6 equals 5. Subtract 6. 4n equals negative 1, divide by 4, and n is equal to a negative 1/4, and that would be then my solution. And again, here we had to know that we could change this into threes, and if you remember, it's divisible by 3 if you can add them all up, and that number is divisible by 3. So 4 plus 2 is 6, plus 3 is 9. That's divisible by 3, and so then you could just start saying, okay, well, let's try to see if we can get something with a base 3, and then you just keep multiplying it out until you get your final number. All right, what about this one? Here we have the 36, 1 over 36 again. Here we have 216. All right, well, remember we said, well, that was equal to 6 to the negative 2 before, and that's b to the b minus 1. So now, can we take and make that into a factor of 6? Well, 6 times 6 is 36, times 6 is 216. So this is 6 to the 3rd. And so let's multiply this out. That's going to be 6 to the negative 2b plus 2 equals 6 to the 3. And now we just set those two equal on the exponents, because now we have like bases. And so we subtract 2 minus 2b equals 1, divide by negative 2. And so b is equal to a negative 1/2. Okay. All right. Now what are we going to do? Well, this one on 8, we have a 4, a 2, a 4. Now, we always want the same bases, so can we combine these two? Well, what is 4? Well, 4 is 2 squared times 2 to the negative 3n minus 1. Now remember, that's 2 squared on the bottom, so if I take it to the top, that's going to be 2 to the negative 2. Now, what do I get when I multiply two numbers with the same base? Well, then I'm going to basically add the exponents. So minus 3n, 2 minus 1 is 1. And so now I have like bases, just one on each side, and I can set those exponents equal. And so I subtract 1, negative 3n equals negative 3, so divide by negative 3. And so n is equal to a positive 1. Okay. And in all cases, you can always check and multiply and put everything back in. So that's going to be, if we plug in a 1 here, that's a minus 3, minus 1, it's minus 4, 2 to the minus 4. So we're going to have 4 and then times, and then that's 1 over 2 to the 4. And 2 to the 4 is going to be 4 times 4, basically. So one of those cancels that. And so we have 1/4 equals 1/4. Okay, so quick check, plug it in, and it does work. All right, what about this one? All right, well, we saw 243 before was a factor of 3. That was 3 to the 5th. 9 is 3 squared. That's 3 to the 5th again. So now let's go ahead and plug everything back in and make it simpler. So 9 is 3 squared, but we're taking that to the negative 2x, so that's going to give us 3 to the negative 4x. Now this is 3 to the 5th, but it's on the denominator, so if I take it to the top, it's going to be, and this time I'm just going to rewrite it here, 3 to the negative 5 to the 3x. And here, 3 to the 5th times that, so it's going to be 3 to the negative 5x. Okay. Now I need to multiply here, so that's 3 to the negative 4x times 3 to the negative 15x equals 3 to the negative 5x. Now remember, when you multiply like bases, you just add the exponents. So that's going to be 3 to the negative 19x equals 3 to the negative 5x. Now we have a single base that's the same. We just set those two exponents equal. Okay. And so let's add 5x, and so we have a negative 14x equals 0, and so basically x is equal to 0 here. Okay, and if we plug in 0 here, that's going to be 1 times, plug in 0 here, that's 1, so 1 times 1 is 1. Here, this to the negative 0 or positive 0, it doesn't matter, it's going to be 1, and so 1 equals 1, and so that does look good. All right, so the next one, we have factors of 5 for our base. Now remember, when we have that 1 there, that really is just 5 to the 0, because anything to the 0 is 1, and so if we use our common base, that would become 5 to the 0. So with the multiplication on the left, that's going to be 5 to the, well, here we have minus 3n plus 2n, so it's going to be minus n. Then we have minus 3 equals 5 to the 0. So, like bases, minus n minus 3 equals 0. Well, this time I'm going to add n to both sides, and then n is equal to a negative 3. And so that would then be my final answer on that one. And again, if you wanted to, you could go back in and check and make sure that actually did work. All right, what do we have here? Well, it looks like 2 is a factor here, 2's are factors here. So what is 4? Well, 4 is 2 squared, and that's to the 2x. And 16, well, that's 2 to the 4th, but it's on the denominator, and I want it on the numerator, so that's going to be 2 to the negative 4. Okay. Well, so here when I take power to a power, that's going to give me 2 to the 4x equals 2 to the negative 4. Now I have like bases, 4x equals negative 4. Now I just solve for that x, so x equals negative 1. Okay. All right, what about this one? Well, these look familiar. They were powers of 2 again. And remember, that's 2, and we saw that over here as 2 to the 4th to the negative 3p. Now, what is 64? Well, if we take that times 4 more, that's going to give us 64. So that's going to be 2 to the 6th to the negative 3p. Or wait, 2 is 32. Yes, yeah, 2 to the 6th. Yeah, 64. Okay. So then we have 2 to the 4 times 3 is minus 12p equals 2 to the minus 18p. And so minus 12p equals minus 18p. So let's add 12p. And so 0 equals, and that's a minus 6p, so p is equal to 0. All right. And if we think about that, that's probably the only way this is going to work. 16 to the 0 is 1. 64 to the 0 is also 1. And so that makes sense. All right, what about this one? 216 and 36. Well, 36 we know is 6 squared, and that's to the 3v. So 6 here, that was 6 times 6 times 6, so that was 6 cubed to the negative 3v. All right, so that's going to be 6 to the negative 9v equals 6 to the 6v. Well, I think this is going to give us the same answer as we got on the last one. Negative 9v equals 6v. So let's add 9v to both sides. And so 0 equals 15v, or v equals 0, because divided by 15, you get 0. Okay, and again, that to the 0 is equal to that to the 0. 1 equals 1. That's a true statement. All right. What about the next one? Well, here we have a factor of 6. Here we have a factor of 6. And here we know that's 6 cubed. Okay, so what can we do here? Well, if you remember, what we can do is we can take this to the numerator and make the negative a positive. So that's going to be 6 cubed. And then times 6 to the 2a equals 6 to the 3a. Now, when we multiply, it's going to be 6 to the 2a plus 3 equals 6 to the 3a. Now we have like bases. We set our exponents equal. And we solve. So I'm going to subtract 2a. And so 3 is equal to a. Okay. And so again, if we needed to, we could plug all that into our calculator. We can see that it does work out. And that would be our final answer then. All right, so that's all I have for section 13.1.